Hello. Thanks to everyone who could join us today. We really appreciate it and do apologize again for our technical difficulties last week. We're super happy that you were able to fit us into your schedule this week. We're very excited about the conversation here today. We have with us Alec Artofsky. He has been a system engineer with SevOne over the last decade. His focus is on data and infrastructure and helping businesses reach their goals. In his time with SevOne, Alec has worked closely with customers and vendors to expand their idea of infrastructure monitoring and getting value out of their data and dealing with next-gen technology like software-defined networking. He spent time working with major enterprises, Fortune 500, of course, CSPs and MSPs. Alec understands the value of data collection and, more importantly, how businesses can use that data. Along with Alec today is Jason Carrier, who is a principal product manager with the IBM SevOne NPM team. His focus is on advanced technologies, including AIOps. He is rapidly fond of pragmatic product execution, radical candor, so please feel free to jump into chat and ask us any questions while we move along. And of course, enterprise design thinking. Jason has a background from as an Air Force veteran and a DoD contractor, and then found his way to Austin attending the MS in Technology Commercialization program at UT Hookham. After graduating, Jason enjoyed the opportunity of serving Texas Venture Labs as a venture partner, so he's very interested in product development, product management, and helping businesses reach their goals. With that, I did want to give a little background on our webinar today. This topic was born from some conversations that we had out at a conference recently. We were presenting SevOne along with our parent IBM, and we got tons of questions from conference attendees on what exactly was AIOps and what was the difference between AIOps and machine learning. So we hope that we put together some great content for you today. A little background on some of the definitions, how those definitions apply to different IT professionals, and we'll take you through some demonstrations of how SevOne solves real problems in customer environments, and a little bit of a preview of our integration with IBM. So with that, I pass it over to Alec.
Great. I think I'm actually Jason. I'm going to go ahead and jump in here. Alec, do you want to say hi to the audience real quick before we kick it off, though?
Sure. Hi, folks. Thank you, Mandy, for that great introduction.
Perfect. And so with that, maybe we go ahead and get started. Yeah. Let's go to the next slide. And the very first thing I want to start this off with, it's a legal disclaimer. We are going to be talking about some futures here in terms of what we're developing. And I'm not a fortune teller or psychic or anything like that. I don't know what the future actually holds. So I want to be really clear that any statements that I make regarding IBM's future direction, intent, or product plans are subject to change and without notice. So we are going to communicate what we currently think the future looks like, but that doesn't constitute a promise to deliver on any specific timeline or anything like that. And with the legal disclaimer out of the way, we can get to the fun part. So first up, I wanted to kind of use some really broad definitions of what we mean when we're talking about AI, artificial intelligence. So it's the big umbrella piece of this is AI. So it's really any technique that enables a machine to mimic human behavior. If the machine is doing something that a human used to do, that is, by definition, AI. A subset of AI is what we call machine learning, and that's basically the math. So the algorithms and statistical methods that help the machines to do some sort of rudimentary learning. And we're going to talk about some specific use cases that are already in the product that kind of meet that definition. And when we get to deep learning, that's a subset of machine learning within this bigger AI bubble that really makes the computation of multi-layer neural networks more feasible. Now that does exist within the world in some use cases, but I wouldn't argue that that's where we're at today in the SevOne product. But I think the definitions kind of help give us a general concept of what we're sort of talking about here. So with that, I think we move to the next one. And so now that we've defined AI, what is AIOps? And this is taken heavily from a Gartner definition that I've sort of overlaid some IBM specific data on top of. AIOps, there's three key concepts that we really need to keep in mind to determine what that is. It's combining a data storage function with an analytics function. And that together delivers a relevant insight to the right person. And so there's two different kinds of AIOps platforms. There's a domain agnostic and domain centric. Domain agnostic example, something that covers like the full, 7 layers of the OSI model, for example, would be like a Watson AIOps. And then there's domain centric AIOps platforms that target a very specific use case that's not the full, OSI model. So examples of that would be like SevOne NPM, which is targeting the bottom 4 layers, or a Turbonomic ARM or Instana APM, which are looking more at the top 4 layers. So AIOps platforms have different functions that they provide, and those functions drive outcomes for the users. In terms of the functions, we're looking at ingesting all the data, determining topology of stuff, correlating different things together, over time periods, doing some recognition on patterns, what's good, what's bad, that kind of thing, and then helping to remediate some of those negative patterns to get back to the good way of things functioning within your network, your environment. So the outcomes that we're really targeting with AIOps platforms are observability and monitoring, managing services, and then automating tasks. And that's enough on that slide. We can move forward. I have two different perspectives here. This is a Gartner perspective on what a general AIOps platform looks like, kind of a architecture diagram. So you can see we're observing a thing, we're providing continuous insights into a service desk. The service desk piece is then providing insights into the automation piece, which is then providing insights back into the monitoring. So this is just kind of a Gartner perspective from 2017 on what a domain agnostic AIOps platform would kind of look like. And then our next slide. This is another Gartner perspective. This one is talking more specifically about what AIOps functionality would look like at the network level. So a domain specific use case. You can see it starts on the left with level 0, where human intervention is still required to perform a task, and works into level 1, where most of the work is done by the human, but the robot's helping a little bit. Our AI is helping. At level 2, there's a little bit of human interaction, and the AI is doing most of the work. At level 3, the AI is doing all of the work, and then beyond that, considering we haven't gotten to level 3 yet, we don't know, right? But this is two different perspectives that sort of capture what AIOps kind of is, right? And so next slide. And what is the point? Like, why are we doing AIOps? Well, it's to deliver a relevant insight. And what that is and why it matters, a relevant insight is something that helps you to make a decision faster. It helps you to optimize your resources in a more efficient way, or it helps you to solve a problem in a more proactive way. So right now, a lot of tools are very reactive in nature. You've got to get the data and do a lot of manual analysis on it, and you're finding out after the fact there's an issue. AI is what lets us get to being more proactive and seeing problems that haven't quite happened yet or that are about to happen. Go ahead and move forward from there. And so as we go into IBM, we're looking really hard at the AI Ops ladder, which is a figure that IBM has put together, kind of a framework to help us figure out where we need to focus in terms of improving our capabilities to better provide AI Ops solutions. So what this means is we start at the bottom with collect. So we collect all the data from all the different devices. We then organize it into a common information model. We can then, once it's in a common information model, we can then analyze it, look at commonality and trends and that kind of thing. Once we've identified those, we can then infuse them into an organization, either through our user interface, data insight, or through integrations like webhooks or APIs, that kind of thing. And so holistically, what this lets us do is make the network data available for a AI and hybrid cloud kind of world. So moving on from there. This is where we're kind of drilling into the specific data that we're collecting. And Alec, I think I'll just talk about this one. Yeah.
Yeah, thanks, Jason. So, all of the concepts that Jason sort of outlined really depend on the fact that you have some ability to collect all of your data, which allows it to end up being intelligent. And that's one of the things that SevOne really is very good at, which is the ability to collect all of the data. So as you can see here, to us, it doesn't really matter what the data is, whether it's standard or non-standard or whether it's flow. We're going to be able to collect all of your data in one single location. So things like SNMP, ICMP, WMI, some very core competencies that you need to be successful. Then we can bring in things like flow statistics, NetFlow, JFlow, SFlow, IPFix, all that kind of stuff. And then we can take it a step further, which is bringing data via CSV, APIs, Kafka, JSON, that kind of stuff. So SevOne has the ability to be the best collector of data at scale, which ultimately feeds this AI vision that we're all coming to, which is the more data I have, the more intelligent that data can be.
Yeah, perfect. And I think we can move on to the when we're collecting all this data and via all these different protocols, it's for a lot of different vendors, right? The days are past when you can just cover observability for Cisco and have the bulk of the internet really shown. There's a lot more vendors out there, and they're doing things in a purposefully differentiating way, which creates challenges. You know, all the protocols that Alec mentioned on the last slide, the vendors don't all implement those in exactly the same way. So there's a lot of complexity in getting all the vendors to work within a single solution. And fortunately, SevOne also has a SNMP based 10-day SLA. So like as a new device comes into the field for SNMP, if it's not currently supported, we have a process whereby customers can submit a walk, and we'll go through and actually pull the OIDs that will populate the information model, our device object indicator model, in the right way within 10 days to add support for that device. In the future, we're actually looking at expanding that SLA to include other protocols beyond SNMP, but we're not there yet. And so now that we've kind of really talked about collect, the other three layers, we're going to kind of roll together. So the organize piece with its common information model, the analyze piece, which includes the backend database and the business logic, and then the infuse piece, which is the user interface and integrations capabilities. Instead of going through those each one at a time, we're going to kind of roll them all up and sort of show you how the where the rubber meets the road with the value that this creates actually looks like. Before we do that, though, we're going to have an opening poll. So if everybody can look in your top right of your WebEx window, you should see a little kind of tooltip pop up over the poll to let you open that up. And once we do the poll, we are going to share the results with everybody so we can kind of see what the group sort of looks like and what opinions are right now. This is going to drive how the rest of the content looks in terms of like which places that we focus in the most. So appreciate your time in filling that out. In the meantime, while we're letting folks do that, if there are any questions, please throw those in chat and we will definitely get those addressed. Makes it a lot easier if we've got more of an interactive conversation than us just speaking into the microphone for an hour. Looking at the results so far, I think everybody should be able to see it in that window that opens up when you take the poll. I see a lot of folks, 6 so far, really interested in live maps topology, and then flow and on-prem observability are the big winners so far here. There are a few that are looking at public cloud observability as well. Yeah, I don't see any more results coming in, Alec. It does look like when we're doing the demo, we can probably focus on the on-prem flow and topology related stuff. So let's go ahead and move forward. And so now Alec is going to run through some use cases that we already have in the product. At the end, if there's any that pique your interest, definitely throw that in chat. We are listening, and we're going to present what the audience is most interested in. So with that, Alec, you want to take it from there?
Awesome. Thank you, Jason. Thank you, folks. So what I really want to kind of walk you guys through is some use cases that we have found that really shows how using SevOne's AI capabilities, we really give users the ability to take their data and make it substantially more useful and more powerful. So really, when I think of SevOne, one of the core pillars of what SevOne does and how it works is this machine learning baseline. So when a device is brought into the SevOne system, automatically by default, for every metric that exists, we begin to create a baseline. And think of this baseline as sort of a normality curve. This is what we expect to see for every metric for every device in our environment. And what this provides is really a great insight into what we should expect to see, not just on any given day, but for every given pull point. So as an example here, what we can do is we can look at a data set and go, okay, well, I might see that there's a large spike, but it might be normal. So the use case I always give is CPU is designed to be used. So you might be utilizing a high amount of CPU. If I look at a baseline like we have here as an example, you can see that we have things like baselines and the standard deviation shading that shows what is normal and what isn't normal. So if the top example here, we can take a look and see, okay, well, we have that massive spike that is outside of the baseline. So that is abnormal. I want to be notified of this. I want to be alerted upon this. The same can be said for the screenshot directly below. You can see that we have the baseline, which is that little dashed line, and the blue shading that corresponds to it. And you can build alert policies around what is normal, what is inside the shading. And as long as I'm inside that, I want to be notified. So SevOne can take your data, understand how your data looks on a regular basis, and then notify you when you deviate from normal. So it is really a key component of how we can just not flood with white noise alerts, but how we can actually notify you when we have actually deviated from normal. And then we can even take that baseline one step further and actually help you plan into the future using things like capacity planning. So if I understand historically what I expect to see, I can help you plan into the future. So in SevOne, for every 6 pull points we collect, we can accurately project 1 pull point into the future. So that means if I have 6 weeks worth of data, I can project 1 week. If I have 6 months, I can project 1 month. So that means I can help you from a SevOne perspective understand when I'm going to run out of available pipe in my for bandwidth, as an example, or when I'm going to run out of capacity for CPU's memory or disk, because I know what we use, and I can see how we are slowly increasing. So I can notify you of, hey, we are going to hit full capacity a certain period of time. We can show in these reports what we expect to see moving forward. So we can actually leverage that historical data we've collected to help you plan forward in your future so you know how long you have until you run out of available resources, something that keeps you from hitting that brick wall long before you have the resources available for you. And time over time thresholding is another component that utilizes that baseline, as we had mentioned, as well as you can utilize it for simple static alerts. So think of this as an example. I can build an alert policy here like we have that says, okay, I want you to notify me if I have a certain number of pull points over a certain number. So as an example, I can say, okay, if I'm over my threshold for, in this case, 15 minutes, which would be roughly 3 pull points, I want to be notified. So what this means is that we can actually build alert policies that are not only just configurable to individual metrics, but are also intelligent in the sense that I can say, don't just tell me if it goes over once. Tell me if this is an ongoing problem. If I see this for 3 consecutive pull points, I want to be notified versus, oh, you're over 90%, here's a notification, but you went over for 10 seconds at 2 o'clock in the afternoon. So not only is it very customizable, but it's also very intelligent in the sense that we can tell it, don't tell me unless you see a certain number of pull points over a certain threshold, which means I'm not just getting bombarded with alerts. I'm only being notified of issues that are actually problems. And this goes back to the item that we talked about earlier, which is the dynamic alerting and using baseline and slope alerting. So this is really a great example. And this is something that I always like to tell. I feel like it's best if a use case is provided for something like this. So I mentioned using baseline alerting, the ability to be notified if you go above or below a certain value, what is normal. But one of the things that's really great in the product, something that we found a lot of value with, is the ability to use slope alerting, or in this case, slope variance. So it's a really great example because it's something that will help you catch large swings in data, maybe in short periods of time. So the best example that I can give, it usually comes with something along the use of like interface speed changes. So every once in a while, you'll go ahead and add capacity. You'll go ahead and you'll make changes for things like port channels, connections, stuff like that, where the speed of the interface is going to vary based upon if anybody's doing work, if there's more people on it, that kinds of stuff. So if we begin to have a dramatic increase or decrease in that interface speed, as an example, that is not something you would normally catch because it may quickly go from okay to not okay, and it'll go inside or out of what would be a normal span for alerting. But if I use something like slope alerting, that will notify me when it does make those large increases or decreases in a short period of time, like you can see here in this example, we can build an alert policy that goes, wow, that was a dramatic change in a very short period of time. I want to be notified. So SevOne really is a full arsenal of the way that we can use this baseline for alerting. I can do longer term, several poll points I want to be notified, or you can build alert policies where if I have a very quick change, I want to be notified. So it really does provide not just one type of alerting. SevOne is using this baseline, this dynamic alerting, to really not only give you the ability to be notified if we have a deviation from normal, but also whether or not it's a long-term change, a short-term change. But the value is that we're not just saying, if I go above X, I want to be notified. We're actually looking at your data, analyzing it, and notifying you when we are deviating from normal. And this is another component of SevOne that I think is really valuable and important, is that you can actually build your own metrics inside SevOne. So using something like synthetic indicators, we can take data sets that we're collecting from a MIB as an example, and actually build our own customized data set. So the example that we use here is combining in and out traffic to build a total bandwidth metric. I can take two data points, add them together to create another data point. So by creating new KPIs, what that means is that you are no longer reliant on what the MIB provides. I can take data sets that have been brought into the system, do mathematical equations, addition, subtraction, multiplication with those data sets to combine them or change them to build a unique indicator that I need that is valuable to me. So it's not just, oh, this is what my device gave me, I'm stuck with this. It's, well, this is great, but what if I was able to combine it with something else that would give me a more valuable metric, like, total CPU as an example, or total bandwidth, or the ability to look at percentage of errors, things that you might not get normally out of the box, you can build with synthetic indicators. Just again, making your data even more intelligent by being able to add or subtract or change that data set to fit what your needs are exactly. And all of this comes back to being notified, the ability to actually have my data. Collecting data is great, but if I'm not notified of issues or being able to understand what's wrong with them, then it's just simply data. And being able to be subscribed to alerts in SevOne is a huge benefit. Not only are we taking that baseline and notifying you of issues, but you can set it up where I can get an email, I can get a text message, I can have a ticket generated, I can have it go up into an event correlator, to be able to just take that data, subscribe to it, have that data posted out to whomever, and then be able to look at it in a very detailed report that helps me understand what my issues are, where they lie, and ultimately get to the bottom of what that issue is. And all of that is available in SevOne. So we're not just a collector of data, we're also here to help you get the data to the right place, as well as be able to understand what that data is and how it directly affects you and your business. And then lastly, this is a new component of SevOne that has been added in a very new release, which is live maps. The ability for SevOne to actually understand the architecture of your environment, automatically build out how these devices are interconnected, how they're all associated, and then show you things like alert capabilities, traffic passing through, and ultimately give you a very quick vision of what my environment looks like without having to do any work and being able to then drill down and access data sets on the fly. So this intelligent map building that we have as part of the system is able to take a device, automatically associate it with the other devices, and see how A affects B and B affects C. So you can take this for your whole environment and see that these colors will change lines based on alert status, how much traffic is moving, and the status of those devices. So you can really leverage this topology so that we can understand how everything is operating with a single click and a single build. So no longer is it I have to lay nodes on a map. SevOne can intelligently scan your environment and place these devices together based on how they're interconnected, and you can get a visual representation of how these devices are all associated. So these are all great components of the SevOne platform that really show how we're not just collecting your data, we're using the AI capabilities of the product to ultimately show how it's all interconnected and how we can make it more than just a collection engine. It can be a way to make your data more valuable to you and more useful.
Great. So now that Alex has kind of given us an overview of a lot of these capabilities that are already baked into SevOne, we would love to show one of them to you. So we don't have a ton of time because we need to get to the rest of the content. But if there is one in particular that you're interested in, please throw that in chat and we will make sure that we cover that. Based on what we've seen so far, I think there's definitely strong interest in live maps and kind of the topology features. So Alec, why don't you go ahead and get started there?
All right, sounds like a plan. Let's jump on into live maps. If I can get my WebEx, there we go. Sorry, the WebEx things keeps popping. There we go. Excellent. So this is the live maps functionality that exists in SevOne, as I mentioned in the previous release. What we're able to do is select a focal device and see how everything is interconnected inside that. So you can see that I've selected this switch here, the Chicago switch. And what I've asked it to do is to overlay all of the connections that exist between this device. So if I wanted to just organically overlay this, you can see that these devices are all directly interconnected to the switch, but we are looking at an actual map of all of our edge routers. So as I showed, I can show this organically, we can show this sequentially, I can show this through a different lens as well. But what we have the ability to do automatically is understand how all these devices are interconnected. You can see that we have tags based on how these links are all physically tagged and brought forward via the MIB. I can see the color is representing to me the alert status of each device and each interface. So I can see that we do have some issues with this switch, this core switch, some firewalls, but the links between them all are green, which means we don't really have any issues. If you look on the right-hand side, you can see that I'm actually getting a breakdown of the individual alerts. I'm understanding which alerts we have. I'm actually even able to get the metrics for the data associated with this. So I can see what the most utilized interfaces are on this map, the amount of ping times, error, that kind of stuff, as well as I can understand a general breakdown of the status of each one of these devices. So if I wanted to outline just one individual firewall, I can zoom in here. I can click on this, just isolate this individual device itself. I also have the ability to go ahead and restructure this if I wanted more information. So if I really only wanted things around, let's just say I only wanted to understand what was going on for my physical links, I can tell the system omit anything that is not an actual physical link, as well as I can have every link in here and understand what's going on. So the benefit of the live maps is that not only is this an automatic creation, this is done automatically by the system when you select a focal device, I can have these lines represent alert status. I can have these lines represent metric data, like how much traffic is flowing over these interface links themselves. And then I can build these out to show me even more specific things, like if I want to show alert policies or things like that. But the benefit of the live maps is that, as I mentioned, you can do it both physically in terms of a canvas. You can use a map, like a geographical map or a Visio map, and overlay them like that as well. If you have latitude and longitude brought in as metadata, I can go ahead and overlay those on a map to automatically overlay those devices for metadata. So the benefit of this is that it is not only just a visual representation, but it is giving me a clear understanding of how each component of my network is operating. And then I can even get more information, as I mentioned, by highlighting individual components. So live maps is a great function. It's a great component of what's going on. It is very flexible in how we do things, but the real benefit is that as a visual representation of a network, that is constantly updating to show me more information about this, so that if I needed a visual representation in, let's say, a knock, or say I'm a visual learner like myself, I can build this, reference it back, and then quickly access more data if I want to drill down into individual links or devices. Jason, that is what I have.
So Alec, we got a question in chat. With slope alerting, is it based on a percentage or what values? Can you provide examples?
So the way that slope alerting works is that it actually uses an equation to operate, to build them. So I don't have the actual equation in front of me, but basically think about it like rise over run. So give me 1 second. I actually might have the equation somewhere, but the whole concept is that we are using slope alerting to quickly evaluate changes in data sets. So when you build an alert policy inside SevOne, you actually have the ability to select things like percentiles. You have the ability to select things like percentiles, standard deviations, and static alerts. And the benefit of utilizing slope alerting is that you can actually tell it whether or not you want to use an RFA, which is sort of rise over run, or the other one whose name, unfortunately, I can't think of at the moment. But the way that we calculate it is, if I can remember what I have for here we go. So the actual equation for which we use is there's slope alerting, what they call DFA, and there's slope alerting RSD, where basically one of them is using the rise over the run, as I had mentioned, and the other actually uses the standard deviation. RSD is standard deviation. So you can think that the DFA version, not to get too technical, is it's using the average points within a window and then calculating the difference between that. So it'll return the value that represents the increasing slope and the decreasing slope at the same time. So DFA is basically what I described. If there's a massive drop in traffic or a massive increase in traffic, that is going to automatically trigger if you're utilizing like the standard deviation between one point and another point. The other is using the RSD, as I had mentioned, which is basically looking for the average deviation during a certain period of time. So if the deviation is quite large, like if you go from 100 to 10, that is something that you might not automatically be notified on if your alert policy is over maybe a 3 pole point span. But if you were to use the deviation between the top point and the bottom point, maybe in a 5-minute window, that would notify you. So I know it's a bit of a long-winded answer, a little technical, but basically SevOne has two different versions of slope alerting. One is actually the standard deviation between the top point and the bottom point, and the other is actually between 2 points in a certain data window. So this is all available in SevOne documentation as well. So if anybody's interested, but that's sort of in a nutshell without going too deep.
Great, thanks for that, Alex. I think from there we could probably go ahead and move on to the next slide, so we've got enough time to cover the whole AIOps integration story. Starting that off, so this is a kind of a high-level picture of the network domain-specific AIOps platform that SevOne provides. So starting on the left here, you can kind of see the enterprise devices that we're connecting to, drawing data from. In the next column, you can see the type of data that we're drawing into our system, where we've collected all the network data and are doing this baselining, ML-based math on everything that we've collected, and then presenting that to the user and fusing it in the organization through an advanced workflow in our data insight application. And then through that, we also integrate the data with webhooks and Kafka bus and other means into other IT operations platforms. And through that, help provide monitoring and troubleshooting, alerting, SLA management, compliance, capacity planning, and also kind of going in that single pane of glass tool consolidation sort of direction. From a SevOne perspective, we're doing that primarily for the network specialists, but we do see users that are coming from security operations as well as service incident and compliance management. So next is why are we trying to connect the domain agnostic with the domain centric. And the reason on the next slide here is because the applications that rely on the underlying network in order to perform. There's no point in having a network if you don't have applications riding over it, and there's no way to provide applications without having the network that it's riding on. So that's kind of why we need these two things to be tied together. We need folks who are managing the application to know what the network specialists are doing, and we need the network specialists to know be able to provide data up to the application specialist so that these two folks can really work together. And so to do that, we need to unify the data. So we do have integrations right now that are professional services provided between Watson, Big Panda, BMC Remedy, MoogSoft, and ServiceNow. The integration that we're going to be talking about today is really a productization of the field service integration that currently exists between SevOne and Watson. And so that specific integration, I've kind of already alluded to this, when we're delivering the right the right insights to the right people, these are the right people that we're really focusing on for this integration. It's not really, this isn't an all-encompassing list, obviously, of all the users that would benefit from the integration, but the two that we're really trying to serve the most is the site reliability engineer, who is primarily a Watson user, and the network specialist, who is primarily a SevOne user. And what we're really doing is tying the network relevant data in with the delivered services relevant data so that we can make intelligent correlations and facilitate the collaboration between these two folks.
Jason, I wonder if our audience is familiar with Watson AIOps, if you wanted to give a little bit of background on that.
Yeah, that's actually on my next slide, so that's a good segue to
Okay,
the next one.
great.
Yeah. So for those who aren't familiar with what Watson is, the IBM Cloud Pak for Watson AIOps is a tool that is a full stack ITOM kind of tool that lets you integrate the data from lots of different services and products. So Instana and Turbonomic and now SevOne, as well as Splunk and a whole host of others, and then do intelligent correlation. And so like cross-domain topology, for example, and help to remediate those by doing correlation and figuring out what's related to what. So when a specific service goes down, correlating the data from all the different monitoring tools together to figure out one cohesive story of what's really happening. That's sort of the promise of what Watson is. So what this specific integration is looking at is taking all of these ML-based alerts that SevOne generates and sending them northbound up into Watson so that SevOne can participate in this correlation and problem identification things that Watson does. So the alerts from SevOne go northbound via webhook. Watson will be able to provide temporal correlation. So based on a time series, correlating the network related events with all the other events that are taking place in the enterprise that Watson knows about, and then letting the SRE know when there's something relevant taking place. The other thing that will be included in that integration is as the SRE sees the SevOne network-based event that's happening, if they want to drill down and get more information, they'll have a really handy in-context link that will let them get right back into SevOne and look specifically at what generated that alert and some more context around it. So this is another view of that integration, kind of stated in a more simple way. So we're taking the machine learning based alerts via webhooks from SevOne, sending those northbound to expose them to the SRE and providing the SRE with in-context drill down back into SevOne. Now, this is something that we're currently intending on delivering beginning in Q2. The drill back piece may wait until Q3. We're still kind of figuring out the specific timelines there, but that gives you a rough estimate of when we're sort of looking at delivering this. And next up, Alec is going to walk through the something that looks very similar to what the productized integration will be, but this is the field service built integration that exists today.
Awesome. Thank you very much. Yeah, so as Jason had mentioned, one of the benefits is, and I touches actually in some of the use cases, is the ability for SevOne to be the collector, alert upon the issues, and then get them up to an event correlator like Netcool as an example. So if you look at this this page here, what you'll notice is that this is just an overarching view of the issues that we have inside our network at the moment. You'll notice it breaks it down by the severity, the number of alerts, the actual alerts themselves. In our case here, we're really interested in these Barcelona type alerts. They're what's kicking up in our use case here. So one of the things that we can actually highlight is the ability to isolate individual alerts inside the system. So if I were to go ahead and just select our Barcelona firewall, you'll notice that I've isolated just out those individual devices and the alerts associated with them. But one of the values and one of the things that we touched on is the actual AI capabilities that exist in SevOne today. So the example that I used in our previous conversation was CPU is designed to be utilized. So if you build an alarm that specifically says, I go above X, I want to be notified for CPU, that's not exactly great because obviously you put CPU to utilize it. By utilizing the AI capabilities inside SevOne, what we can provide you as an alert like this, where, excuse me, where it says is if my usage of my CPU is above what is normal, I want to be notified. So by utilizing the AI capabilities inside SevOne, I can actually already be pre-selecting my alerts to things that are actually issues. And then when we have that, we can actually even go a step further and get more information. So as I keep saying, SevOne has its own AI capabilities, one of which is it actually understands what devices are. So if you look at this, I clicked on the name of our Barcelona firewall. It gives me 3 locations I can go. One of the locations tells me to go is a Cisco ASA device summary. So the system actually already knows that this firewall is a Cisco ASA. It is smart enough to understand it's an ASA, and it takes me to a report that is ASA specific. And if we look at this report, you can see that we have the alerts that we saw on the previous page, again, utilizing AI capabilities that we have in the product. We're getting things like reachability, current connections. You can actually see we had a massive drop in connections. Active tunnels seem to be fine, RAS sessions, SSL sessions, something like that. So we see that we have that massive drop in connections. And if you look at the report, you can actually see that in very recently, in the last 5 minutes, we've had a massive drop in connections. So there is clearly something going wrong that's not allowing us for VPN users to actually connect back to this ASA device. But the alert that we saw was around CPU. So we're going to actually jump into CPU. And as you can see here is, wow, all right. So if I hover over this, you'll see that we're pretty much moving along. We've had a little bit of a spike here. But if we look here, you can notice that if I hover over this, in the last 5 minutes, we have had a massive increase in CPU utilization, which is what those alarms were telling us. So you can see that in real time, as we begin to have issues, the system is not only going to notify me of the issues that we're having using the AI capabilities, but then we can also see them in reports themselves. So what we really want is more information around what the heck is going on with these CPUs. And one of which is I can actually drill in from a report into another report. And you'll notice in the upper left-hand corner here that we're following through what we like to call the breadcrumbs. The ability to actually find a issue, like the alert that we had on the first page, move into a device summary report specific to that device, and then even go one step further and actually isolate those individual data sets. And you can tell we've all done that with 3 clicks. So anytime you see a word that's highlighted blue, what that means is that there's more data that's available to be accessed. So again, more AI capabilities of the system is not just the data collection, but the ability for the system to actually correlate your data and give you access to reports specific to the data sets we're looking at. So one of the cool things that you actually have the ability to do in SevOne is the ability to overlay data sets together that are not specifically associated. So you can see we're still looking at our Barcelona firewall, we're still looking at our CPU issues, but what I want to do is I actually want to go ahead and overlay those connections with the CPU issues that we've been having to see whether or not that increase in CPU actually matches up with that drop in connections. And you can see, since it is so recent, it's a little difficult to see, but you can see if I hover over this, we can see that we've had that massive drop in connections when we had that huge spike in CPU utilization. So we actually have the ability to overlay data sets together in SevOne that might not be directly associated to be able to help us get to a resolution faster. So we can see that those items are actually correlated. I can jump back using my breadcrumbs back into my Cisco ASA device summary here. And typically, one of the things that you'll notice is that when you have a large increase in CPU, something is eating up that CPU. And traditionally, that would be a process. So what we can look at is actually the processes that are running on this individual firewall. if we sort this by max, just because we're curious to see what the heck's going on, we can actually see that our SSL processee here is the one that is utilizing most of the individual, is utilizing most of the processes here for CPU. We can see if we look at the average CPU time of this, maximum, we're hitting at 105 here. And if we hover over this, we are really way up there. In this case, we're at 104.3. So it's fair to say that this SSL processing is eating up CPU. So you can see how we can follow through this, how we have the ability to actually correlate these data sets together with simple clicks. And then lastly, again, pulling all of these use cases together, we can actually then again look at how using the baseline can help notify of issues that we've had. So if we isolate this individual time span here, I'm actually going to make this a little bit easier, reduce the time span to 4 hours. You can see that the baseline for this is typically around 13.5. We have way spiked above that. If I can get my mouse to select something here, we're actually at 109. So you can see that that is the direct correlation as to why that alert was triggered. Because our baseline was roughly 13 and a half, you can see that traditionally, as long as we're between 0 and 33.38, that is considered an acceptable range of deviation, so no alerts would be triggered. But because we've reached 109, an alert was triggered, which ultimately said that we have an issue itself. So all of these have basically shown why the alert was created. Now, one of the huge benefits is that we can actually pop into Netcool and understand sort of if Netcool has the ability to correlate individual data sets. So if you give me 1 second here, we can see that Netcool itself, or excuse me, IBM Watson Netcool, is actually gone ahead and looked and seen that we have a group of issues here. Netcool is actually taking all of these alerts that have been triggered. You've noticed that there were several CPU alerts, all kinds of issues. We can look at this and see that Netcool has actually gone ahead and correlated these items all together in the system. So we can see that I had to expand this because it went ahead and correlated these items. For our Barcelona firewall, it is determined that the connections issue, the CPU issue, and the SSL issue, all of which that we covered inside SevOne, are all associated together. They're all correlated. And the system has gone ahead and done that. It actually already has a probable cause for what is actually causing this issue. So the benefit is that SevOne itself provides the ability to collect the data, alert upon the issues, and we even walked through and showed how A equals B, B equals C, C equals D. But Netcool has actually gone ahead and taken all of those alerts and already correlated them together to telling you that this is an issue that seems to all be associated. And what's really cool about this is that we can go ahead and actually isolate these individual alarms or alerts that have been coming into Netcool, now using IBM Watson's AI capabilities that we've done here to correlate these devices. And as Jason had mentioned, we actually can jump back into SevOne. So we started in SevOne and ended up in Netcool. You could start in Netcool, see that we have this alert, this correlated event, and then dive back into SevOne to actually be able to begin to do the investigation that we did. We also have the ability to launch a runbook, which means we can actually take an action on the events that are being correlated inside SevOne. So I can go ahead and say, all right, well, we can see that we have an individual issue here. In our case, one of the things that I sort of brushed over is that what we can determine is that this is a DDoS issue. We can actually take a look at our connections here. And if I were to go ahead and pull in the flow statistics that are associated with SevOne, I can actually look at this report and understand that during this period of time, that large increase in processes is around a DDoS attack. It's a denial of service attack. So clearly something is coming at SevOne, something is trying to shut the system down, something is trying to disrupt what's going on for your firewall. So we went through, we found the processes, the CPUs, all of that stuff. And the benefit is that what Netcool actually was able to determine, as well as SevOne can help determine, is that this was a TCP SYN basically flow attack, which is a DDoS attack. So that runbook that I've isolated here, what we can actually do is go ahead and run this runbook, which will go ahead and take the IP addresses that are peppering the firewall with actual packets and trying to shut us down, the DDoS attack. We can run this runbook and actually go ahead to, oh, sorry, I think I clicked the wrong button there. I can actually go ahead and run the runbook, which will go ahead and actually stop these IP addresses from hitting SevOne. So I can go ahead and click run, and what it will do is it'll go ahead and take the IP addresses of what is attacking that firewall. You can see received status of normal. We'll go ahead and actually stop those IP addresses from reaching that firewall. And what we'll be able to see over time is that these individual spikes, the drop in connections, the increase in CPU, the actual DDoS packets can be stopped by running a runbook inside IBM Watson Netcool. So really, one of the huge values of this integration is that it can be accessed from twofold. You can start your day in Netcool. You can see that we have an event that's being correlated. I can jump into SevOne directly from Netcool to then investigate what is going on. Or I can look at my alert structure from SevOne using the AIOps that's part of the SevOne platform natively. Begin to see that we have large increases in CPU. Follow the workflow through that we followed here, going through the processes, the CPUs, that kind of stuff, and then going to Netcool and understanding whether or not those events are all correlated. So this relationship, this back and forth that we have is really quite powerful in the sense that we now have the ability to take the AIOps capability that is native inside the SevOne product, as well as the AIOps capability that exists in IBM Watson Netcool, and correlate them together to even make your data even more valuable than it was before. So by being able to take these two things, we can correlate them together and actually give you guys the ability, as you can see here, to resolve the issue at hand. If you take a look at these reports, you can see that we are actually going back to normal since we've gone ahead and blocked those IP addresses and stopped our DDoS attack. So it's just another way to take your SevOne data and make it even more valuable. And now with the power of being able to be integrated with IBM Watson, we can even take it one step further. So that's a demonstration I have, Jason. I will go ahead and pass it back to you.
Perfect. Thank you very much for showing that, Alec. I really appreciate it. So looking at this from a big picture again, now that Alec has really walked us through how this works, we can see that SevOne plays a really important role and can really provide a lot of value to the whole IT operations ecosystem using the AI capabilities that are intrinsic to it, as well as by capitalizing on the AI capabilities that are in other products like Cloud Pak for Watson AIOps. And for those that aren't familiar, you might have noticed that Alec was using the word Netcool a lot, but here we're talking about Watson. They are kind of the same thing. Watson is the umbrella piece that is pulling a whole bunch of products that existed bespoke in the past, kind of pulling those all together into a single offering. And so there's a whole bunch of things that are included in Watson, and Netcool is one of those. So I just wanted to clarify there. And then last, I do want to make sure that it's really clear the integration that Watson, or that Alex showed here just a minute ago is the field provided solution that exists now, but does take professional services. And what we'll be releasing in the Q2, Q3 timeframe is a productized version of that should be a lot easier to implement and not require special services in order for folks to take advantage of. And I think last, we have a closing poll. We really appreciate everybody coming and giving us your time and attention as we try to demystify AIOps here. This poll will kind of give us some data and some feedback in terms of what we should be doing going forward, as well as give you an opportunity to have someone reach out for further conversations, or if you want to just jump on a call to kind of discuss what we're thinking and how we could better serve your needs, that kind of thing, we'd be happy to do that too. So, just request that call back in the poll there, and someone should be reaching out to you. With that, that is all the content that we had for you today. We'd be happy to take any questions or go ahead and answer those here live while we've got a few minutes left. One question that came on, we're talking about 3 different platforms, SevOne, Netcool, and Watson AIOps. It's actually 2 different platforms. Netcool is part of Watson, and as I covered before, or mentioned before, there is a consolidation effort that's going on with that team that is kind of re-envisioning Netcool into part of a broader offering. But the integration that we're talking about in the Q2, Q3 timeframe with SevOne would apply to both of those, whether you have the Netcool product that is not part of the the cohesive Watson suite, or if you have the netcool that's already been baked into the cohesive suite, this integration would work for you. Yeah, really appreciate everybody's time and attention. I think we could probably go ahead and close it there, yeah.
Well, thanks so much again for everyone's time and rearranging your schedules to come out this week versus last week. We do appreciate that. Thanks so much again to Alec and Jason for taking us through very complicated and very technical topics. I definitely feel much smarter. And please answer our closing poll. We did get some good questions here today. So if you're interested in getting a deeper dive or a discovery meeting with our teams, we're always happy to meet with you and partner with what your needs are for your organization. Thanks again for your time today.